All right, let's use do another example of conditional probability, and more specifically the multiplication rule for conditional probability. We're going to use a standard deck of 52 cards again, and we're going to draw two cards out. There's a first and a second. So, before we begin, just as a reminder, remember out of the 52 cards, half of them are red. 26 are red. 26 are black. How many jacks are there? 4. How many diamonds are there? Diamonds, there are 13 because diamonds are one of the 4 suits. Hearts and diamonds, spades and clubs. Hearts and diamonds are the red cards, 13 each giving 26. Spades and clubs are the black cards, 13 each, also giving 26. Okay, so I'm not going to use the formula for all of these because these are so simple that we can do it without plugging into that formula every single time. But for the first one, I'll do it. The probability that the first is red and the second is red, that's the probability that first is red times the probability that the second is red, given that the first was red. Right? So the probability that the first one is red is 26 out of 52, which is 1/2. Half of them are red. But for the second card, given that the first one was red, we only have 51 cards left. And one of the red cards has been removed. It was the first card. So the second one being red means there are only 25 left out of 51. So again, if you want to write that as a 1 fraction, I'm not going to pull my calculator out, but that's the answer. All right, so again, this was pretty simple. You get 26 out of 52 to get the red card. Now, one of the cards is gone. One of the red, and you only have 25 red cards left. 25 and 51 total cards. 26 out of 52, then the remaining 25 out of 51 are red. So it's 26 over 52 times 25 over 51. The probability that the first is red and the second is black. So it's going to be the probability of getting a red card on the first one times the probability of getting a second card being black, given that the first one was red. So maybe I'll write the formula out one more time, or be more formal this way. It'd be the probability that the first is red, first is red, times the probability that the second is black, given the first is red. So for us, that's going to be the same start, 26 over 52, times, now what's it going to be? What's the probability that the next card, the second card, is black? Well, there are only 51 cards left, but there are still 26 black cards because the first one taken out of the deck, the one that was removed, was red. So it's going to be 26 out of 51. Remember that out of the remaining 51, if the first one was red, you've got 26 black ones left and you have 25 red ones left out of the 51. So the first is a jack and the second is a jack. Well, the first task is to be, what's the probability of choosing a jack? 4 out of 52. But now there are only 51 cards left, and one of the jacks is gone. So you have 3 out of 51 left as the probability of the second one being a jack. 3 over 51. And what is that 3 over 51? It's the probability that the second card is a jack, given that the first card was a jack. So originally you have 4 jacks out of 52, but after the one jack is gone, you've got 3 jacks out of the remaining 51. All right, the first is a jack, and the second is not a jack. Well, the first one being a jack is 4 out of 52. There are 4 jacks out of the 52 cards. times the second card. Well, there are only 51 cards left. And how many of them are not jacks? Well, 3 of the remaining would be jacks, so 3 from 51 would be 48. So they were very similar, the previous two problems. The second card was a jack because there are 3 out of 51 that are jacks. The other 48 out of 51 are not jacks. All right, part E. The first is a diamond and the second is black. So what's the first one? The probability that the first one is a diamond. Well, let's see. How many diamonds are there? 13 out of 52. The second one is black. How many cards are left? 51. That's how many are left in the stack after you take one out. How many black cards are left? Well, the red one came out, so you still have 26 black cards. And the next one is very similar again, similar to the previous one. The first one is a diamond, the second one is not black. So there are 13 diamonds out of 52. And then out of the remaining 51, we took a diamond out, so that's red. So how many non-black cards are there? Actually, I could have said that the second is red. Not black means red. So instead of 26, it would be 25. Again, not black means red. So if you pulled out a red one, a diamond is red, there are only 25 red ones left out of 51. Okay, so one more for this video. I noted that it's a pretty easy problem. A box contains 5 red marbles, 6 green marbles, 2 white marbles. So I sometimes like to draw a picture. That's the box. I'll just make a note: 5 red, 6 green, 2 white. That's what we've got. 3 marbles are drawn with replacement. What does that mean? It means you draw it out, you note the color, and then you throw it back in. You replace it back into the box. So what we're going to do, since 3 marbles, we're going to draw one, put it back. Draw another one, put it back. Draw another, put it back. So is it possible that each time we pull out exactly the same marble? Sure it is. A little unlikely, but it certainly could happen. So let's find the probability that the first one is red, the second one is green, and the third one is white. This is just the multiplication principle, really. We're going to multiply 3 probabilities together. What's the probability that the first one is red? Well, let me make a note. How many are in this box? 6 and 5, 11, 12. So we have 13 total. So when we draw one out, what's the probability that the first one that we draw out is red? 5 over 13. Times, remember we put that red one back in, so there's all 13 are back in the box. What's the probability that the second one is green? Well, there are 6 greens, so 6 over 13. And then we pull that green one out, we put it right back in, so we've got all 13 back in the box. What's the probability that the third one is white? White. There are 2, so 2 over 13. That's it. And so if you wanted to write them as one fraction, you could write 5 times 6 times 2 over 13 to the third power. And again, I'm not going to plug it into the calculator, but this is the exact answer. All right, the same problem. This time we're not going to replace it anymore. All right, so I want to know the probability that we get a first one red, second one green, third one white without replacing them. So I'm going to multiply 3 numbers together. What's the probability that the first one is red? Well, it's going to be exactly the same, 5 out of 13. Now that red one is gone. Now I need to say, what's the probability that the second one is green, given that the first one was red? So now we're down to 4 reds. So what's the probability that the second one is a green? it's going to be 6 out of 12. Right? There's 12 left. And now, the second one being green, we just removed it. So now we're down to 5 greens. And for the last one, the third one, what's the probability that it's white? 2 whites out of how many left? 2, 5, and 4. 9 is 11. So it's 2 out of 11. Notice the denominator is decrementing by 1 each time because we're not replacing the marble that we select out of the box.